This is CSF4203, Chapter 4, Week 8, Frame Relay. We will be discussing frame relay, what it is, how to configure it, and how to troubleshoot, like we did with PPP. So what are the benefits of frame relay? They are, instead of doing private line for all your links, if you remember last time I told you that the telecom provider, like Salat, they will charge you. But if you have frame relay, it will cost you less. It will also reduce the number of dedicated equipments and devices. It will reduce complexity for network managers. You will attend. Okay, so we reduce complexity for network managers, a greater bandwidth flexibility in the private lines, lower cost for ownership. These are all, and bandwidth utilization. These are all benefits of frame relay. The virtual circuits in frame relay, there are different types. We have SVC, switched virtual circuit, established dynamically by sending signaling messages to the network. And we have permanent virtual circuits, PVCs. They are pre-configured by the carrier. And after they are set up, only operate in data transfer and IDL modes. Please, when we ask you about what do you know about PVC, don't forget to mention these 2 points, okay? How do we identify VCs? We identify them by DLCI. I told you about DLCI last time, remember? DLCI 102, DLCI 201, DLCI 103, DLCI 301. DLCI has no significance beyond the signal link. The single link. And you have a name here. When it arrives there, it has different name. From here, it is called DLCI 102. At router 2, it is called DLCI 201. So it's only significant at the local link. Here we have multiple virtual circuits. So here we have DLCI, the red color or orange color, brown color, I think this is. What color is this? This is brown, red, and green. Okay, you are testing me, right? I'm not colorblind. Okay, Alhamdulillah. Then we have the green. Green here is 319. So this is how multiple virtual circuits, they are identified by different DLCI numbers. This is frame relay topology. Here we have a frame relay star hub with one physical link carrying 5 virtual circuits. You see here, this is your headquarter. You see how many links? These are virtual circuits. Here we have mesh topology. Each DTE have one physical link carrying 4 VCs. So everyone is connected. We will do only static mapping and virtual. We'll do 2 labs. Okay. If you will major in networking, then you can take more advanced courses. Then you will be working more on not only frame relay, also in more like you will be working on different technologies. Okay, like MPLS. Okay, remember MPLS we talked about last time? MPLS depend on labels. To forward the message, the router will depend on the label of the message. That's why it's very fast. Okay, this is the frame relay address mapping. This is how we are going to do it in the lab. So you will call the interface, you give it IP address, you assign the encapsulation to frame relay, then you do the configuration for frame relay. As simple as that. If you do show frame relay map, it will show you the map that you have just created. Okay. And you see the DLCI number 102. Okay. And the link is active. Any questions? This is the frame relay example also here. This is what we are going to do in the lab, by the way. So here we have 3 routers. Okay, we have DLCIs from router 1 to router 3, router 2. All right. And these are the information. Do you know what is CIR? Committed internet rate. Yani how much they are going to give you, which rate they are going to give you, the carrier. Because you pay by these amounts. It's expensive. It's not cheap, this one. Okay. To configure frame relay, we are going to do this in the lab. So I will skip this one. This is, we have already talked about the command and the mapping. Why we need to use the broadcast command, which is optional? It allows broadcast and multicast over the virtual circuit. This permits the use of dynamic routing protocols over the PC. Yeah. To verify, to troubleshoot and verify, we use the command show frame relay map. It will show you all the mapping that you have with the DLCI number. DLCI number. Okay. You apply it to router 1, router 2, and router 3. Everything we will do in the lab, by the way, we will do it on each router. So when I explain the lab, I will do like maybe router 1, and then I will ask you to do router 2 and 3. Okay. To troubleshoot connectivity, you can do show interfaces serial, and then you give the interface number. And you see here, it will show you the LMI, DLCI number, the LMI type. This is, by the way, sometime coming in the exam. Okay. How do you know the LMI type used for frame relay? Okay. And this is a DTE, not DCE. Okay. Also, we can check the status of the DLCI link or the PVC link. This will show you specifically for this DLCI 102. Okay. Is it active? And here you can see FECN and BECN. What is this? Very important. This will test the link. It will tell you if FECN and BECN about forward congestion or backward congestion. So that you will know that when the bit arrive, when the frames are arriving, they will tell you, I came from a congested area. Okay. And forward, when you are sending, it's telling you ahead that this is congested. So this is the meaning of BECN and FECN. BECN is backward, FECN is forward. So this is the summary. Please read the summary.